Hey, I have something here that looks very familiar to something you've all seen. You guys have all probably seen Wilson's theorem that goes like this. If you have a prime number p minus 1 factorial, okay, that's congruent to negative 1 mod p, congruent to minus 1 mod p. Okay, and I guess it's conventional to put the parentheses there like that. Okay, but this is very well known. It's not too hard to prove. You get a bunch of inverses that pair up together to be congruent to 1, and it kind of works out fairly nicely. Now, if you'll take a look at this proof, it's very similar in structure, except we're given that A is a composite. Okay, and so we're supposed to show that A minus 1 factorial is not congruent to minus 1. So this almost follows immediately just from the definition of what it means for something to be composite. A composite number is a number that has two divisors. In this case, we call them B and C, that are strictly between a 1 and A. And so we have A is equal to B times C, which makes A a composite. That means it's not a prime number. Now, so we can write A minus 1 factorial in this fashion. Okay, B and C are definitely going to be in this string of factors based on this definition of the compositeness of A. And so it really, you see, it works out fairly nicely here. When we rearrange all of this, we actually get BC right here, which is just equal to A, right? So BC is just the same thing as A, and the rest of this is just some constant. We'll call it M if you want to. And so what we get is that A minus 1, you can rewrite this. This says that A minus 1 factorial is a multiple of A, but that's equivalent to just saying A minus 1 factorial is congruent to 0. And this is just the definition of congruence, congruent to 0 mod A. Whoops, congruent to 0 mod A. And we've actually shown, see up here it says we're supposed to show that this is not equal to negative 1. Well, we've done even better. We showed that it was congruent to 0 right down here. We showed that the whole thing was congruent to 0. So we've proved what we set out to prove, and I hope you enjoyed.